All right, everybody. We're going to quick take a look at Chapter 1 closure. So this is just going over everything that we've learned so far in Chapter 1. And some of these problems really make you think. So it says, the activities below offer you a chance to reflect about what you have learned during this chapter. As you work, look for concepts that you feel very comfortable with, ideas that you would like to learn more about, and topics you need more help with. All right, so it might be a little challenging. First off, it talks about summarizing our understanding. And for this first part, it says, Candy Calypso, the CEO of Moon and Mercury Candy Company, has a crisis. She has hired your team to help her solve a problem. A customer ordered 1,000 bubblegum machines and specified that each one should have a probability of exactly one-third for getting a blue gumball. The bubblegum machines were created and sent out, but the customer has called, claiming that the machines were filled incorrectly. Candy's records show that each machine was filled with 4 yellow gumballs, 8 red gumballs, 16 green gumballs, and 20 blue gumballs. So now we're going to work to figure out whether the machine meets the customer's requirements, and if they do, find at least 2 other combinations of gumballs that would satisfy the picky customer. And if it does not, then we're going to find at least 2 ways to adjust the contents of the machine so that the probability is exactly one-third. All right, so here we go. Let's try to create this, see if it works. So the problem is that there is a one-third chance of getting a blue gumball. But then Candy's saying that isn't accurate because here we're getting 20 gumballs that are blue out of, let's see how many total we have. 4, 12, 28. If we add those numbers together, and then we have to add our 20 still. So it'd be 48, our total. So blue is our desired outcome or expected outcome. We want blue out of the total of 48 total gumballs. All right, so is 20 over 48 equivalent to one-third? Well, looking at this right now, I know it's not, right? I know that 2 does not go into 48 3 times. So let's say what we would need to make it 1 out of 3. Well, let's say we kept blue the same. What would we need 20 to be out of in order for it to be equal to one-third? So in other words, one-third is equal to 20 over what? Well, here we had to multiply by 20. So then here we have to multiply by 20 as well. So now I have 20 out of 60. That would make it so blue is one-third of the gumballs. So we could just add 12 to our total. Maybe we add 12 green. Maybe we add 12 yellow. All right, whatever you'd want to do to make it so that there are 60 total gumballs and 20 of them are blue. So that's one way that we could adjust it. Let's think of another way. Maybe instead of changing the total, we change our part. Maybe we change our 20. So what would 20 need to go to so that it's one-third of 48? Well, let's think about this. We want to get it to one-third. And right now, we have 48 as our total. Here we're going to change our part. So what would you need to divide 48 by to get to 3? Well, let's see. 6 goes into 48 8 times. So that means 3 goes into 48 16 times. Okay. So I had to divide 48 by 16 to get to 3. So now I'm going to divide my mystery number here by 16 to get to 1. Well, if we want to figure out what that mystery number is, we could just do 1 times 16, work backwards. And if we do 1 times 16, here we're going to get 16. All right, so these are two ways that we could adjust it. We could either subtract 4 gumballs from the machine, or we could simply add 12 to our total. All right, do you guys see these two ways? Add 12 of different colors. Or subtract 4 blue. Then we have 1/3 probabilities. All right, notice these are a little bit more challenging. They require a little bit more thinking. So we're going to work to solve these problems that we have now. Vanson, I don't know if I've ever heard that name, has a bunch of boxes that are all the same. He stacked 4 boxes, measured the stack, and found that it was 3 feet high. All right, so we could write this as 4 boxes was equivalent to 3 feet high. And so now it's saying, how high will a stack of 20 boxes be? Okay, so I'm going to set up my new fraction in the same way, because it looks like we're working with a proportion here. So instead of having 4 boxes, I have 20 boxes. Now the key here is that since boxes was on the top here of our old fraction, boxes also needs to be on the top of our new fraction. That way we can make them equivalent. All right, so we had to multiply 4 by what to get to 20? Well, I know 20 divided by 4 would be 5. So I multiply by 5. So if I multiply my feet by 5 as well, I get 15 feet. So it's saying that if 4 boxes was 3 feet high, then if we have 20 boxes, it would be 15 feet high. These fractions would be equivalent. All right, so now it says part B. The ceiling in the room where Vanson is working is just a little more than 9 feet high. He wants to stack boxes from the floor to the ceiling. How many boxes will fit in one stack? All right, just a little more than 9 feet high. So here, I'm going to take a look at how many boxes do we have for 3 feet. And we were just saying here with our fraction that we have, 3 feet would be 4 boxes. And so now if we were working with 9 boxes, or excuse me, 9 feet, how many boxes would be in one stack? So I have to multiply by 3 to get to 9, so I multiply 4 by 3 to get to 12. So 12 boxes. And it does say just a little more than 9 feet high. And so if you want it to be just a little bit more, you could say 13. All right, kind of depends on how you perceive the problem. Next one says, find the perimeter and area of Jacob's swimming pool shown in the diagram below. Be sure to show all of your work. So remember, with perimeter, are we talking about what's on the inside or the outside? Remember, think perimeter, that's going to be like a fence or the out of bounds line on a soccer field. And then my area is going to be my backyard or the field itself. So fence is on the outside. Like if I'm buying fence, I only want to buy for the outside of my yard. And then if I'm buying sod or grass to lay down in my yard, then I want to buy for the inside. So if I'm looking at the outside right now, this is kind of an interesting shape, but I can simply try to figure out what are all the measurements on the outside. Here I'm given 18, 6, 11, and 9. So what would be this measurement? What would be this measurement over here? Well, we might have to add a little bit. Okay, on this side, I have 18 and 11 as my two lengths that are going this way. So that's going to be this entire length here. So if I add 18 plus 11, that's going to give me 29. Make sure I label 29 meters. And now if I'm trying to figure out over here the height, well, now I'm paying attention to my 9 and my 6 because they're both going up. So this is my height. So 9 plus 6, that's going to give me 15. Don't forget my label, 15 meters. So now I would take 15, 29, and then I would multiply each by 2, so 15 times 2 and 29 times 2, because it's a rectangle. Oh wait, no, it's not a full rectangle, is it? So what do we have to do instead? Figure out all the sides, so what do we have to do with the sides? We have to add them all together, right? So if I add 15 plus 18 plus 6 plus 11 plus 9 plus 29, what is that going to give me? That's going to give me my perimeter, okay? So calculate that out, make sure you label, that's going to be your perimeter. Next we're looking at area. Let me get rid of all this. Area is a little bit tougher here. I notice it's not a rectangle, but can we find some rectangles inside of here? Well, I see a rectangle here and a rectangle here. So 1, 2. What is my height and base of this one? And then what is my base and height of this one? Well, I know that the base here is 18 for my first rectangle. And then my height, that's going to be here, which we said if we take 9 and 6 and add them together, we're going to get 15. So 18 times 15. That's going to give me my area of triangle 1. And then if we do base, which here we see is 11, and our height of 9, that's going to give us the area for rectangle number 2. So once we find the two areas for rectangle 1 and rectangle 2, what can we do with those two outcomes? We'd add them together, right? So if we do 18 times 15 and then add that to 11 times 9, that's going to give us our area. Now, remember, that's going to be in what label? Meters, right? But since it's talking about the inside, it's going to be meters squared. All right, so go ahead, find your answer there. Next, we're looking at probability. Tuan is playing a game, but the spinner is incomplete. If the numbers in the section of the spinner represent the probabilities of spinning each section, help him figure out the fraction for the missing section. Okay, so I need to figure out what can I divide this entire spinner into to make it a good spinner for all these probabilities, because that'll help me figure out this missing piece. All right, so what I'm going to do is look for first a common denominator. And if I have 4 and 5, well, let's see, the factors of 4, that's going to go to 20. The factors of 5, Ooh, that also goes into 20. So I'm going to make these fractions out of 20. So here I have 1/4, and then I have 1/4, and then I have 1/5. So I'm going to make these all out of 20. I'm going to transform 1/4 into 5 out of 20. Multiply both by 5. This would also be 5 out of 20. And then 1/5 I would transform into 4/20, right? If I multiply both of these by 4. So if I do 5 plus 5, so 5 plus 5 plus 4, that's going to give me 14 over my denominator of 20. So how many do I have left to fill this final section here? Well, I could do my whole 20 over 20, that would be the entire spinner, and subtract 14 twentieths. So my missing piece would be 6 over 20. Now, can we simplify this? Yeah, we can divide both by 2. So let's go ahead and do that. Divide by 2, divide by 2, and now we have 3 over 10. Can we simplify this? No, there is a number that goes into each of them. So 3 out of 10 would be our final part of the spinner. And then you could just double check by adding up all of your spinner pieces together, and you should get 20 out of 20. All right. Now we talked a lot about this. We'll do this real quick. So here we're writing percentages and fractions and decimals. So let's say I have the decimal 1/6. Or 1/6. How would I convert that to a decimal? Well, remember, if we had like 8/2, that's like saying we could just do 8 divided by 2 and get 4. So here it's the same thing. We can just divide that top number by that bottom number to get our decimal. So here if I do 1 divided by 6, I get 0.166666. So it's 1.6 repeating, or 0.16 repeating. And then as a percentage, well, we just multiply this by 100. And if we do that, we're going to move that decimal place over 2 places. And now I have 16.6%. Notice I included that 6 here because remember, that's a repeating 6. So I can't just forget about it, right? We could write this as 6666666, but we're just going to keep it as it is. So we are done with that one. So think about how we go from percent back to decimal. Instead of multiplying by 100, we might do the opposite. And now if we move that decimal place 2 places to the left, 0.4, and then 0.4 as a fraction. Well, we could write it as 40 over 100 because that means out of 100. But if we wanted to write it simply reduced, we could say 4 out of 10. And is there still a number that goes into both of them? Yes, there is. 2. So divide both by 2. And now we have 2 over 5. All right, that last one I'm going to leave for you guys to complete. This time, instead of being out of 100, we have to the 1, 2, 3, the thousandths place. So here my fraction is going to be over 1,000. All right, what would our top number be? Final one here. We've been doing a really nice job of this, finding a common denominator for both of our fractions. In this case, what does 2 and 6 both go into? That's what you have to figure out. And then once you make these both out of 6, remember we add those numerators across the top. And then what is that going to give you for an answer? You guys are doing well with the theoretical experimental probability, so I don't want to spend too much time on it. Just remember, theoretical. That means what we think should happen. We haven't quite conducted the experiment yet. Experimental. What has actually happened. It's like we tested it out, ran the experiments, recorded the data. All right. So this is going to be like in past tense. I drew. I did this. Theoretical. That's going to be future. Like if I were to roll a dice, what are my odds of landing on this? All right. So go through, complete those. You guys are doing a really nice job with these. All right, we're going to look at this final part here. So this first problem says, what is the probability of landing on gold if I have 1 gold, 2 silver, 3 green, 4 blue, 6 are red, and 9 are yellow. It's like we have a lot of pieces here. Now, what do we do with these pieces to find our total? Well, our total is going to be all of these added together. So if I do 1 plus 2 plus 3 plus 4 plus 6 plus 9, that's going to give me my total on the bottom. And then we're looking at what part are we looking for? We're looking at our gold. That's going to be our part. So how many golds are there? Here I'm looking for how many golds there are. It says there's just 1. So it's going to be 1 over my total. Probability of landing on yellow is 36%. What is the probability of not landing on yellow? Key word here, not. So what would be the probability if all of your pieces were yellow? Well, it would mean that you have a 100% chance of landing on yellow. And so if we wanted to figure out the probability of not landing on yellow, well, we'd have to subtract what our current probability is. So all of the spinner pieces minus how much of it is actually yellow. And that's going to give us the probability of not landing on yellow. So what is that going to give you for an answer? Finally, we have if the wheel is spun 100 times, how many times would you expect to land on silver? So here we have 1 out of our total. Or excuse me, now we're talking about silver. So now we have 2 out of our total. And now what if our total changed to 100? What would you have to multiply your total by to get to 100? And what would you have to multiply your numerator 2 by to get to 100? All right. So go ahead and work on these. And that'll be the last one I'll have you guys do for today. All right. Don't worry about this one. This is a little fun one, a little puzzle mystery for you. So if you want to take on the challenge, go for it. Otherwise, the other ones are learning targets that we have talked about and worked on a little bit. All right. Thank you, guys.